Hello, my name is Vedant Patil. I am an intern in Sparks Foundation and my task is stock market prediction using numerical and textual analysis. Here I have downloaded my libraries which are NumPy, Matplotlib for visualization, some statistical models I will be using. I've used Yahoo Finance data which is past 15 years data from 2005 to the current year 2020. As this is a time series analysis, I have taken care of the date column, which is in this format: year, month, and date. So depending upon the data, it should be sticking to a particular format where you will be able to handle all the analysis which you will be carrying forward. I've set the date column as my index column for the entire data set. Here I have done some feature engineering. This is a cross autocorrelation plot with the lag of 3. So lag of 3 means the distribution of the point, or the distance between each point. I have kept it as 3, and this is how the data is overall looking. Here I have just plotted a column from the entire data set, the close stock price column. This is uh, this is the visualization of my training and test data set. So as you can see, 70% of the data is trained data and 30% of the data is test data. I will be using auto ARIMA model for forecasting. So ARIMA model depends upon three main features, or you can say three main parameters, that is P, D, and Q. P is past values used for forecasting the next value. Q stands for past forecast errors used to predict the future values, and D is the order of differencing. So why auto ARIMA model? Because hyperparameter tuning for ARIMA model consumes lot of time. That's why I have used auto ARIMA, which actually does half of the work for me. So it is just upon a slight of parameter tuning, and then you are ready to go. So there's a one magical function which model offers, that is the fit function, which is actually allocating you certain combinations of P, D, and Q values, these values, and the model runs by, after running the model, it gives you a suitable predictions. I would like to highlight these two estimators which ARIMA model uses, that is AIC and BIC. AIC stands for Akake Information Criterion, and BIC stands for Bayesian Information Criterion. These are just estimators. So this is how my ARIMA model is forecasting the data. This is my overall performance score, what my model has predicted. There are two types of plot which ARIMA model is actually related to, that is PAFC plot and ACF plot. So PAFC plot is a partial autocorrelation plot, which helps you in actually getting the auto regression in the role, and ACF plot is basically dependent upon the Q feature. It is determined by the Q feature of the auto ARIMA model. Here I have used stacked LSTM. LSTM is long short term memory. This is a short diagrammatic representation which is not actually precise to what actual LSTM is, but this from here you can see that there is one input and one output, which is connected like in a conveyor belt of a company. For example, you can say there are multiple production tests which a product goes through. So in LSTM, it is the same thing. On every section there is a information. So information in LSTM is actually stored into different memory blocks, which you can say uh, in technical term it is called as cells. Information in this LSTM flows through a mechanism called as cell state, and small modifications done in LSTM are done through simple multiplication and addition calculations. This is my validation data, and here I've created small for loop for processing the data. This is usual training and test set what I will be feeding to my LSTM model. Here I've used, as I said, stack LSTM. So these are my actual layers. This is my the model.add is my output layer, and I have run the model for 100 epochs using batch size of 64, and my LSTM model is functioning pretty well. This is my overall performance of the model, a small visualization wherein you can see what my model has actually predicted. It is pretty much similar, and you can say LSTM has worked very well. As per the task, I have built a small hybrid model for predicting for 100 days. So these are 100 inputs which I will be giving to my model. This is where I will be feeding those 100 inputs, and I will be getting a y hat value for the output of this model. This is the prediction which I will be getting for BSE Sensex stock, and as you can see, the stock is will be going a downtrend. But usually, I would like to say that stock of a company is actually dependent upon multiple factors. For example, I have taken here news analysis, or you can say news headlines, which are based upon the sentiments of the news. So it is one of the factors where you can say that the stock is gonna go uptrend or downtrend in traditional stock market language. Further, following the procedure, I have done textual analysis, importing the required libraries for sentiment detection. Here just I've downloaded the data from News India headlines, so we'll be covering the headlines from 2001 to the current year. Further, I have just done some feature engineering, keeping date as the point of concern, as I have said. My keeping this format as same because it won't be a problem later. This is how I will be cleaning the headlines, removing the category from the entire data set, because I don't need this category label over here. And then I will be merging this analysis of text with the previous data which I've got. This is the sentiment score about every news. Like you can say, the magnitude of each news is divided into 4 parts. You can say compound, negative, neutral, and positive. So for example, if you take a news which is light combat craft, take India club class hawk. So the overall compound magnitude of this sentiment is minus 0.3612 as predicted by my model, and it is pretty much helpful for a stock trader to know that this news is not good for a stock to rise. Therefore, I have merged these two data sets so that I can get a clear view about what actually a sentiment can play a role in this entire stock market prediction. Further, I will be feeding all these predictions to random forest, decision tree, and XGBoost, where you can see that my decision tree is performing very well with 80% of accuracy, whereas XGBoost and random forest are giving me satisfactory results, not so good. These are my references from where I have referred, or where I've done my entire analysis. I would like to thank Sparks Foundation for giving me an opportunity, and thanks for watching.